Hello, everybody, and welcome to Windmill. Windmill is an open source developer platform to build all internal tools from scripts, schedules, webhooks, flows, and custom UIs. Today, we'll explore the Windmill app editor that allows you to build custom UIs from components and connect them to scripts and flows. For the example, let's take an AgGrid table because it's a powerful component to display data. As you can see, the data source can be either static, as it is now. See, if we change age from data source, it will be displayed as well in the component. But you can also set a data source from a compute, which means a script or a flow. Scripts can be supported inside script, Python, Go, SQL, etc. We'll pick SQL and choose a custom database from Superbase, actually, with our connection string. Let's set the SQL script to select all from table called demo. Okay, nothing displays. That's normal because we need to update the current definition as well. For example, city and ranking for that table. Okay, but we'll delete that script and instead fetch data from a publicly available API. So as you can see, we picked REST, which is under the hood a fetch-only TypeScript. Okay, so we'll go to sample APIs, which is around our website, to pick APIs and replace the placeholder by our link. We don't need the input here. We can run the script and see that we have indeed a result. Let's update the column definitions with title, calories, and total time, for example. And this is instantly displayed in our table. We can change custom configuration like the height of displayed rows. Okay, as you can see, we have a problem. Some numbers like calories are empty. So we modify the script. We can either do it manually or ask AI to change it. Here, not returning objects where calories or total time are empty. It requested changes, we run it, and it's updated. Okay, so let's do a first deploy of the app to save it and allow saving later. Good. Now let's give a title to our app. So as you can see, the template uses a context variable with our username. Here we just want to display available recipes as a title, and it works perfectly. We can move components just in drag and drop. Let's add another component to ask user to select cuisine. We'll make it a subtitle, and you'll see that from the data source, each recipe has actually a cuisine, like American, Italian, etc. So we'll want the user to pick a cuisine from a select component and display only results of that cuisine. So select component can be set statically, what we will do here. So let's set as values are American, Asian, and Italian. You see that there is a display value and an actual value. Okay, so everything works. We need to add an emoji for Italian, which is not so important. Okay, that's good. And you can see on the left that depending on what we pick, we have the result. Now let's ask AI to take as input a string called cuisine and only return the objects where cuisine equal that object. And by default, it is all, meaning everything will be returned. And you can see that the AI is quite fast and reliable on it. And once again, we could have written all that code manually. Okay, we'll test from the auto-generated UI on the right with American. And it works indeed. So now we'll connect the input cuisine of the script to the result of the select component. And everything works perfectly. That's great news, but as you can see, we need to do some styling here because select cuisine is not perfectly displayed. So you have the choice to do like preset styling as we have here on alignment, or you could also do CSS or Tailwind CSS as we'll show later. So here we filtered based on the component, but AgGrid supports directly in-component filters, which allows to do less computations and faster results. Okay, now let's add a new component called container. It allows to host and contain components together. As you can see it, but with some custom styling. So here in Tailwind, we could add, for example, some background and rounded corners. And now we can see the container and place peacefully components inside. The first one will be image. So you can set an image either in static or dynamically. So you just see that we made a cut and paste the image to put it directly within container. And for the image, we can set it either statically, meaning downloading it, or dynamically, here selecting photo URL of the selected row. And now every time the user will select a row, the display image will be the same as a recipe. Okay, let's add some styling as well. Rounded corner, a big border of green color, for example. Okay, it's not totally pretty, but it works. All right, as you can see, we are missing some images, but now you know what we are doing. We are asking the AI not to return objects where photo URL is empty, and I'm doing it with AI because I'm lazy. I could have done it totally manually within the code editor. We accept, we run, and now we have only objects with a photo. Cool. Okay, so now what if we want to display some text based on what the user picked? We can select the text display component and connect it to component A, so the AgGrid table, selected row, and ingredients. Okay, that's cool. We'll add some styling, so text in slate and smaller text. So as you can see, this is very easy. Okay, we need to add a title, correct ingredients, and now you know how to do it. And we can see that everything is perfectly dynamic depending on the row we select. Okay, let's add a new component called slider. The slider allows you to pick a number between a certain range. Here, let's say 1 and 4, because it will allow us to dynamically set the quantities of ingredients depending on what the user picked. So as you can see, for now, the ingredients are set like in static. But you can create a script in Python this time to take an input string and a number as input and multiply the numbers between the input string by the input number. You will see in practice, it is more simple than it looks. Again, the AI is super useful on this. Okay, so for the input string, we need the selected row ingredient. And for the multiplier, we need the result of the slider. Okay, let's try. So now 1 is selected, so nothing changes. What if we select 4? Okay, it seems to work. And let's try with the fractions. And indeed, it seems to work. So it's not perfect, of course. We made it quite quickly, but it seems quite efficient. let's add another component called icon to display an icon from the Lucid library. Okay, we are quite happy with the result. Okay, so now let's add a very useful and common component called button that triggers an action when clicked. So we could either link it to a script or just to a URL on success. And now when you click, you go to the recipe of the displayed cooking. So as you could see, the display and aspect of our button is quite normal or ugly. So we'll take inspiration from Tailwind UI just to show you that any Tailwind classes works directly in the styling menu. Let's just copy paste it. And now we have a picture button. That was the same, of course. Okay, so now let's explore what we can do with Evals. So for the purpose of this, we'll display some nutritional information of each recipe. So let's do it within the container. For styling purposes, we set it in white. Okay. And display elements like sugar, protein, fiber of each recipe. So for this, we need a text display component, make it subtitle, display it on the bottom. Let's see how it looks. Okay, that's good. And now we'll use an eval to display elements of the selected row. Here, for example, calories, but we want to handle the case where calories would not be filled. So we'll use a JavaScript expression to display nothing if calories is null or empty. It will be useful, for example, for sugar or fiber that is sometimes missing. So let's do the same for sugar, fiber, and protein. Okay, let's try. Okay, and as you can see, it's empty when it needs to be empty. Okay, and we'll do the same process just to display the label of each element. Let's do that in fast motion because you don't need to see that again. Just note that once again, we use some Tailwind CSS, and at this time, we are writing calorie, sugar, fiber, and protein, depending on if it was empty or not. Okay, so as you can see, some components are not properly displayed. It's easy to move it in drag and drop, and now everything works perfectly. Cool. So now let's do completely different actions and interact with third-party services. For example, we'll want to send an email with the selected recipe. So we'll use another container. Note that they are not at all mandatory, but we use them just for styling purposes. Let's give a title to the container, like for example, share recipe. Okay, it's not properly displayed. It's our fault. Good. And move it a bit. Okay, it looks like almost a pretty app. Okay, so now, guess what? We'll use again 2 containers, give them white background and rounded corners. As you could see, we could directly copy-paste components with the same configuration. Let's save it as a draft, not to have bad surprises. And within the right container, we'll add a button. So last time we linked a new URL to the button. Now we'll link a script. So no need to display a text. We'll add an icon directly within the component with the send horizontal icon. Let's put it in dark and select a script. So we'll use a script from Hub, which is Windmill's public library of scripts and flows. You could also select one from Workspace or create one. So within that script, it has like 5 inputs in the main function, which are the auto-generated UI that you can see on the right with Google Auth, to email, etc. It will allow us to set those parameters either in static or dynamically. So we need the user to fill information like who to send the email to and the topic. So for that, there is a dedicated component called the form component, where you can directly add arguments. For example here, to, which is a string that we set with a regex to be an email, and default, which is the email of our founder. We'll add another argument called subject with default call recipe that is a string as well. And on the right, we'll add a text area, which is like a text input component for the actual content of the email. We'll do some custom styling to have it in picture, like no border. And we don't need a placeholder, just a default value. So we'll use an eval as well. So as you can see, you can always connect it to other components. So for example, here we'll connect it to the default email. And we can see that it is indeed displayed. But now I'm going to paste a more complex pattern using just JavaScript evals to say like, hey, and the first letter in capitalize of the to email. We'll pick as well the URL of the recipe and the total time as said by the API we fetched. So now every time you pick a recipe, you have the URL and the total minutes that change. And every time you change it to email, you have the name at the beginning of the email that changes as well. Okay, so now we just need to connect our script to the arguments we just gave. So to email, subject, and content. As for the Google Auth, we'll use a resource, which is a rich object linked to a secret that, of course, I'm hiding now. Okay, so maybe we want to try if it works. So let's do it in preview. To have a proper view of our app, we'll add some email address, pick a recipe that we like, and click on the button and check, okay, it was already sent and received indeed. Cool. So now let's add some custom and cool styling to our app. We'll use the dynamic styling feature to allow us to set colors depending on the color within the picture. So for that, we need code, and we'll ask Python to fetch an API, take the photo URL, and return the closest tailwind color from that picture. So here we fetch again the API from the table. We could have done it otherwise, but this is the fastest way to proceed for this time. So as you can see, the script is a little bit longer than the others, but we'll check if it works properly. Okay, it takes a little bit longer, of course, because it needs to open and analyze every single picture from the URL, but it seems that we have colors indeed. So now we select some styling of our image. set the border green to a dynamic class and replace the green by an eval, fetching the ID of the selected row and taking the associated color from the background runnable we just set. So I did not explain, but the background runnable is a script or flow that is not directly linked to a component. And okay, we can see that it works. And the result seems quite decent. We have like red or green colors that take their source from the picture. We'll do the same system for the button to have like consistent styling. And it works indeed. As you can see, it's like a cool feature that is used for styling. It's not crucial for the app, but still enjoyable. For clarity, when we name the background runnable and test our app, so one default of the process we just made with colors is that it needs some seconds to fetch all the colors. We could take them from a database and have no waiting time, but we don't want to use third-party database for this example. Or maybe something you could do to fetch the results only once is caching them. Through the cache the result feature, you can define any time in which the results will be saved. And for the last time in this video, we'll just have to wait for the colors to be found, and they will be available anytime within the range we defined. And just know that any features from Windmill Script Editor and Flow Editor are directly available within the app editor. Let's go back to our app, and everything seems to work. We already tested the email sending. Okay, so you've seen most of the Windmill app editor. So we'll deploy this app. We could also show you some other cool features. So for example, other components, of course, that are numerous and super useful. You could also create your own components either by grouping them with the group fields shared among all components, or even cooler, import your own components from React or Vanilla. Okay. And those components can interact with the rest of the app. We could do also some app styling, meaning at the app level. We could, for example, save some custom CSS or create it ourselves with selectors, depending on components. For example, for Windmill buttons, all buttons, we set color to aqua. It's quite ugly, but it works. Okay, so now I think you've seen most of the app editor. You can now create your own apps and enjoy the rest of Windmill. Thank you.